you a short talk about the approach in Hidalgo to provide a web-based visualization. Here again, the note that this session will be recorded, so keep that in mind. First, I want to give a few words about the project Hidalgo. It is founded by the Horizon 2020 Framework Program and is carried out by 13 institutions from 7 countries. Our mission is to develop novel methods, algorithms, and software for HPC and HPDA to accurately model and simulate the complex processes which arise in connection with major global challenges. The use case we consider are epidemics in terms of COVID spread, migration, social networks, and urban air pollution. For the visualization methods I present today, the simulation data of the urban air pollution use case is used. The vision of this use case is to provide citizens and policymakers with forecast and reanalysis at very high resolution for urban air pollution using science and supercomputing resources through an easy web interface. My talk today focuses on the easy web interface and how we implemented it in our software environment at HLRS. We use for scientific visualization our so-called cave. We will see a lot more of the cave in the next talk, but I just want to mention here it's a small cubic room where we are able to create a virtual environment by projecting rendered images on the walls. Several people can collaborate in the cave in the same virtual environment. It is possible to use shutter glasses to get a three-dimensional view with an amazing immersion. I don't know if somebody of you ever tried this, but it's really awesome. You should do it. The data generated in Hidalgo's urban air pollution use case, it shows wind and air pollution processes which are perfect to visualize in such a three-dimensional environment. The software we use for rendering is named COVISE. COVISE is mainly used for this cave system, but it can also be run for head-mounted displays or on your personal computer. CoVISE is available on GitHub. It is open source and it comes with a graphical user interface which allows well-organized data processing in the so-called map editor. Here I have a screenshot of the CoVISE GUI. You can see the map editor on the left. And here it's organized with so-called modules. So the blue rectangles you can see, these are the things we call modules. And you can just place them by drag and drop from the list of modules you see on the left. So we have many modules available, which can be categorized as read modules, filter modules, and render modules. The render module used in this example gives us a three-dimensional view on the PC screen. This also allows interaction. So here you can, this visualization, you can just turn it around and you can zoom in, and it's also possible to animate it. And here we have some kind of different approach for the web visualization. So instead of this rendering on your PC on the screen, we implemented a module to save this visualization as an HTML file on your computer. How does it work? This HTML file allows us to do the rendering in the browser. It uses the XFreedom format, which is the successor of the WRML format and is approved as 3D web standard. This also allows us easy integration of our visualization in websites. You can just put it in there within an iframe, which is also the approach we will use in Hidalgo, because we are planning to give our users a web-based portal, and within this portal we will integrate this web visualization. This is how it looks like. I just took a screenshot of it. We have a rudimentary graphical user interface, which allows us to toggle different parts of the visualization. So I would like to show this in action. So I prepared a simple visualization of our urban air pollution use case. Now I hope I shared the screen correctly. So you should see now this map editor I talked of. Here you can see this is prepared for the urban air pollution use case. And on the top, we have a lot of reading modules. They read in the structures, the surroundings, like buildings and the streets, railways and the ground. And to the right, we have a big module. This is called Read Insight, and it reads in the data which was generated in the urban air pollution simulations. So all this data is read in, and then it's processed. This is also done by the modules. So you can change the colors, and you can filter the data if you want to see something specific. For the simulation data here, I used the streamlines to make the wind visible. And then it's processed as tubes to have not only just lines, but some kind of tubes, some kind of three-dimensional structures, and the coloring. And all the data is then collected in this Wormel renderer. And here you can also see I can specify the path where the file should be saved. And this is quite convenient. You can just press this execute the whole pipeline button here. And then all the things are done for you. You can just lean back and enjoy the moment when your visualization is generated. And I also prepared this because it's taking a few seconds. It's not so long, but yeah, you know. Okay, so this is when you open this. So here you can see there is a big sphere around the whole data set. I can just enable or disable this sphere here in the graphical user interface. So let's have a look at this. This is the city center of Stuttgart. So our city is not shaped like this, but this is just the area we are looking at. So you can see some buildings and streets, and I can also move this around with my mouse, and I can zoom in and zoom out again. And I can, of course, toggle all the different shapes we are seeing here. And what I also can do is make the time steps of the wind simulation visible with this slider button here. So you can see I can go through the time steps and make them visible in my browser. Quite convenient, quite easy. The dataset also includes a simulation of NOx in the air. This is not yet implemented here, but it would be also possible to have the NOx concentration visible just in your browser. Yeah, quite easy. So that's it from my side. Next up is Uwe Wessner. He's gonna do a cave presentation. He's gonna tell us a bit about digital twins of cities, which is also used in Hidalgo, and a bit about the tsunami visualization of cheese.